Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. So welcome back again with me, Mr. Naufal, in the chemistry course. And today I will present about the elements and also compounds. So please keep your attention to this material because because this topic is very new for all of you. And yeah, before we go deep into the chemistry, before we go deeper into the chemistry, we need to understand about the elements and also compound first. Okay, so let's start the presentation. But before I discuss about the elements and also compounds, I will show you a video. So let's pay attention to the video first.
Stated Clearly presents What is an atom and how do we know? Atoms are the fundamental building blocks of chemistry. Just like baked goods are made of a collection of different types of ingredients, matter itself is made of a collection of different types of atoms. Scientists have discovered 118 kinds of atoms, which we call elements. You can find them laid out on a chart called the periodic table. All things from the screen this video is displayed on to the eyeballs with which you're watching it are made of atoms, but a single atom is so small it is impossible to see with the naked eye. So there you have it. A random voice from a video you found on the internet claims that everything is made from invisibly small atoms. You may now blindly accept this as fact and happily move on with your day, right? No? Now you are extra curious? You want to know for yourself exactly why it is that scientists think they know that atoms exist? Well, to find out we must travel back in time to ancient Greece. Meet Democritus, the man that many historians credit for first clearly proposing the idea of an atom. In his day, it was thought by some that if you were to chop up a piece of matter, an apple for instance, you could just keep on chopping forever and ever. There was no end to smallness. For reasons not fully agreed upon by historians, this concept did not sit well with Democritus. Instead, he insisted that at some point, you would reach particles so small and so indestructible they could not be divided any further. He called them atomos, or atoms, which means uncuttable. Now, Democritus didn't actually have any evidence to back up his claim, and because of that, many people simply rejected it. After all, that which can be asserted without evidence can also be dismissed without evidence. Let's fast forward several hundred years and hop on over to the Arabic world. You probably know that salt can be extracted from seawater by simply letting it evaporate or boiling it dry. People have been doing this forever, but alchemist Jabir ibn Hayyan and those that followed his work took the science of extraction to a whole new level. Through careful experimentation, they developed complex processes of filtration, boiling, vapor collection, and cooling. They found that crude starting materials could be divided into multiple incredibly pure substances. Pure meaning they appeared to be consistent all the way through, unlike the complex mixtures of matter often found in nature. In the 1700s, a French husband and wife scientific duo, Marianne Poltz and Antoine Lavoisier, studied and built upon the work of their Arabic predecessors. They found that certain pure substances could be broken down even further through chemical reactions. Water, for example, can be boiled into steam, which is still water, but it can also be split into two pure gases, hydrogen and oxygen. No matter how hard the couple tried, however, they could not reduce oxygen or hydrogen into simpler gases. They concluded that the gases must be elements, foundational substances that cannot be created by mixing other chemicals together and cannot be broken down any further. With this concept in mind, scientists everywhere began searching for and listing as many elements as they could, eventually discovering all 118 listed on the modern periodic table. Some, such as oxygen and hydrogen, are gases at room temperature. Others are solids, such as elemental carbon and gold. Others still are liquid at room temperature, mercury and bromine. It was also found that under the right conditions, pressure and temperature, certain elements will react with each other upon mixing to form new substances with new properties. These are called compounds. The elements oxygen and iron can react to form a brown powder known as rust. Oxygen and mercury react to form a toxic orange powder. Oxygen and hydrogen react to form a clear, refreshing liquid. You probably know it as water. Though this
So that's the end of the video, and now we move to the next topic. So I guess that all of you may find or may hear a new concept like in the video, like elements, atoms, compounds, and also molecules. And yeah, in this session, I will explain what is elements and what is an atoms. So I'm sorry, I will turn on the printer. Okay, so based on the video, we know that everything in the universe are made up by some basic substance. And what is the basic substance itself? So in 1661, a scientist named Robert Boyle gave the name of the basic substance as the element. So which means the elements itself that made up everything in the universe. That's the first concept. And the second one, in 1803, John Dalton suggests that each element was composed of its own kind of particles, which he called an atoms. And what is the atoms itself? The atoms are the smallest particle of matter that still have chemical properties. So in the second concept, just please understand that this term, okay, the atoms are the smallest particle of matter that still have chemical properties. And for the third concept, because John Dalton stated that each element was composed of its own kind of particle and the particle itself is called the atom, so the definition or the third concept can be extended to include the fact that each element is made up of only one kind of atoms. So the first concept is the elements is a basic substance that made up the everything in the universe. And the second concept is the atoms are the smallest particle of matter that still have chemical properties. And the third one is the element is made up by only one kind of atoms. And because atoms are the smallest particle, so it is impossible for all of us to see the atoms by the naked eyes. So we need to use the equipment like electron microscope. So we by using electron microscope we can see the atoms in real. Okay, so that's the concept. And yeah, the term of elements and atoms may be like very similar, but just remember the concept that element is basic substance, atoms is the smallest particle, and the third one is element is made up by only one kind of atom. Okay, next. Okay, I have the example of the element. So the first one, gold, carbon, and also iron. So let's analyze the element. The first one is gold. So the gold itself, the gold is called element because it cannot be broken down into any other substance or any other element. So if we zoom in like trillions of times and we can see the atoms, and the atoms itself is called gold atoms because if we move back again to the third concept that element is made up by its own kind of atoms, so the gold element is made up by the gold atoms itself. And it is the same way with carbon and also iron. So the carbon elements is made up by carbon atoms and iron is made up by iron atoms. So in carbon elements, we will not found any gold atoms, or maybe in iron we cannot found the carbon atoms. Okay, so that's the example of the element. Okay, so we move to the next topic, and the topic is about the type of elements. So the elements itself have two types. The first one is metal, and the second one is non-metal. I mean, to make it easier for now, I just make it into the two types, because later in the future you may find that the element also have any other types. Okay, but for now I just make it into the two types. Okay, and next we will see the differences between metal and non-metal element. In the term of property, in the physical state at room temperature, the state of metal is usually solid, and for the non-metal, it can be solid, liquid, or gas. And also for the melting point and boiling point, the metal is very high. So if you want to boil a metal, or if you want to melt a metal, you need a high temperature. So it's like 1,000 degrees of Celsius. Okay. And for the non-metal, it is very low. So it is around maybe minus degree of Celsius for the non-metal. And also for the conductivity, the thermal and electrical, the metal has a good conductivity. Meanwhile, the non-metal is very poor of conductivity. And there is one metal that the state is liquid in the room temperature. The name is mercury. Okay. Now we move to the next topic. The topic is about the distribution of metal and non-metal in periodic table. So if you guys wondering what is a periodic table, so the periodic table is a table that scientists fill it with the element. So the chemists or the scientists use a symbol to label the element. So every element has its own symbol, and the symbol consists of one, two, or three letters, the first of which must be a capital. Where several elements have the same initial letter, a second letter of the name or subsequent letter is added. So I give you the example here. So the C symbol is used to represent the carbon element, and Ca symbol is to represent the calcium element, and Cl symbol to represent the chlorine element. So as you can see here, the first name is the same. The first letter is the same. It is a C. You guys can see here. But for the second letter, it is different. So for C, it is just a C, and for the Ca, calcium, it is added an A, because the C itself is already taken by a carbon. So the calcium use a symbol of CNA, and for the chlorine also use the symbol of CNL. And some symbol seems to have no relationship to the name of the element. For the example, Na for sodium and Pb for lead. This symbol come from their Latin names. So if you see here, the C is a carbon because they have a relationship. So the carbon itself, the first letter is C, and also the symbol is C. And for the calcium, because the first two letters is C and A, so the symbol is Ca. And for the chlorine also, the first letter is C and the third letter is L, so the symbol is CnL. And it is different with Na and Pb because their symbol comes from their Latin names. Now, as you can see here, this is the periodic table. So this periodic table is filled by the element that scientists first found. So honestly, don't want to discuss more about the periodic table, because this topic will be later discussed in a few meetings. But now I just want to show you the distribution of metal and non-metal elements. So for the metal elements, it is represented by the red one. And for the non-metal is in the yellow. So For now, scientists already found around 118 elements, but there are some resources that said scientists already found around 150, 116, 117, but according to the IOPAC, the official one, so the modern periodic table is contain 118 of element. It is included the natural one and also the artificial. So that's for the distribution of metal and non-metal element. Next. Now we move to the next topic. It is a molecule. So what is a molecule? So the molecule simply said that it is a small group of atoms. So when the atoms of some elements are joined together in a small group, we can call it as a molecule. So for the example, the atoms of the element of hydrogen, oxygen, and nitrogen, and so on, they are each joined in pairs, and they are known as diatomic element. So let's see the example here. So this is the example of the diatomic elements or a molecule. So as you can see here, each element is, or each element, yeah, I mean each atoms are joined together with their same atoms. Like for the hydrogen, they pair with the hydrogen atoms, and with hydrogen atoms, and nitrogen also nitrogen atoms, and so on. So it is a molecule when there are some atoms of the same element joined together. So that's for the molecule. Okay, now we move to the next topic, and the topic is about compounds. And what is compounds? So the compounds are pure substance which are formed when two or more elements chemically combine together. And the example of compound is water. So water is a simple compound formed from the element hydrogen and oxygen. As you can see in here, in the picture right here, so there are two elements. First one is hydrogen element and the second one is oxygen element. So what happened when they chemically combine together? So when they chemically combine together, they will create a new substance, and the substance is called as a compound because it is composed of two or more elements. So it is different with the molecules because the molecules is just with the same atoms. So the atom of hydrogen and the atom of hydrogen pair together, so it is a molecules. But if there are some different elements or different atoms combined together, so we can call it as a compound, not as a molecule. Okay, because we refer to the definition of the compound itself, because the compound is formed when two or more elements chemically combine together. So of course it need a different element to combine. Okay, and this is the end of the session. So thank you for all of you. Thank you for your attention. And now I have a quiz for all of you. It consists of 10 questions, like a multiple choice. So please fill the quiz because it will assess you like how far your understanding about this topic. So thank you. Assalamualaikum warahmatullahi wabarakatuh.